to take a look at this sequence. Let's write out some terms. When n equals 1, we're going to get b sub 1 is going to be 1/2. When n equals 2, b sub 2 is going to be 1 over 2 times 3, 1/6. b sub 3 is going to be 1 over 3 times 4, 1/12, ... right? So that sequence, if I write out b sub n as a sequence of terms, it goes 1/2, 1/6, 1/12, ... And if I want to try to find whether the sequence converges or not, I will investigate the limit of it, which when I multiply that out, the limit as n approaches infinity of n squared, 1 over n squared plus n is 0. These terms are tending towards 0, so therefore the sequence converges to 0. What's interesting about the sequence, 1 over n times n plus 1, is it can be decomposed into partial fractions. Using our skills from partial fractions, we would get, when we let n equal 0, we would get a is equal to 1. And when we let n equal -1, we will get b is equal to -1. So another formula for this sequence, besides 1 over n times n plus 1, is 1 over n minus 1 over n plus 1. And that's an interesting formula. If I use that to write out terms, this term of 1/2 then can be written as 1 over 1 minus 1 over 2. And that 1/6 can be written as 1 over 2 minus 1 over 3. And that 1/12 can be written as 1 over 3 minus 1 over 4. It's just another way to write out the terms, besides writing them out as 1 over n times n plus 1, we can write them out as 1 over n minus 1 over n plus 1. So my next question is, we know the sequence converges to 0. What about the series? Investigating the series means that we're looking at the sum of the terms. That's how we consider the sequence, right? Does it find out if, or how we consider the series. Does this series converge or diverge? So we can look at it as a sequence of partial sums. The first term, remember, was 1 minus 1/2. And the first sum then would be the same, 1 minus 1/2. The second sum, remember, was 1/2 minus 1/3. So that was the second term. So the second sum would be 1 minus 1/2 plus 1/2 minus 1/3. The third term was 1/3 minus 1/4. So the third partial sum would be 1 minus 1/2 plus 1/2 minus 1/3 plus 1/3 minus 1/4. What would the nth partial sum look like? Well, the nth term in the sequence is 1 over n minus 1 over n plus 1. And the nth term in the sum would be all of the terms added up until you stop there. Oh, wait, let's put one more. Right? And then all of the terms until you end at that one. 1 over n minus 1 over n plus 1. That would be the nth partial sum. I guess I used capital N in here, okay? So if I want the sum of the series, what I want to do is calculate the limit as n approaches infinity of this formula for the nth partial sum. I don't have much of a formula, though. What I have here is just a bunch of terms written out. But I want to try to take the limit of that as n approaches infinity. Of 1 minus 1/2 plus 1/2 minus 1/3 plus 1/3 minus 1/4 plus ... 1 over n minus 1 over n plus 1 is the last one I'm going to add on. Okay, let n approach infinity. Note what happens here. We call this a telescoping sum because these terms are like doubled back on one another, like telescoping and canceling. That negative 1/4 is going to cancel from a positive 1/4 that's sitting in here. And this positive 1 over n, that's going to cancel from a negative 1 over n that's coming before it. So really all I have when I'm taking this limit as n approaches infinity is the number 1 minus 1 over n plus 1. That's the only things I have left. Now, if n is approaching infinity, this piece right here is going to 0. So that limit will go to 1. That means that that infinite sum from n equals 1 to infinity of b sub n converges to 1. The series, the sequence of partial sums, and thus the series converges to 1. Let's take a look at this in Desmos and see if it checks out. So when I use my Desmos sketch and I take a look at it, I put in the series formula or the sequence formula right here, the way it was originally given instead of in partial fraction decomposition. And I can see that the sequence terms are going to 0. There's the 1/2, there's the 1/6, there's the 1/12, right? They're going to 0. So is the sequence of partial sums or the series. That's converging. It's just not converging to 0. It's converging to 1. Look at those terms. The first partial sum is 1/2. The second partial sum is 2/3. The third partial sum is 3/4, etc. And we can actually show a lot more rows here and see how this that series seems to be getting closer and closer to 1. There it is up to 0.98. There it is up to 0.99999 with 10,000 terms. So the series is converging on 1 while the sequence is converging on 0. I'd like you to try this question now. What about this sequence? Ask yourself first, does the sequence converge? If so, to what? Does the series or the sequence of partial sums, which means you'll have to look at the sequence of partial sums, converge? If so, to what? Well, when you went to find the sequence, whether or not the sequence converges, I hope you wrote out some terms. The first term would be positive 1 because it's negative 1 to the second. And the second term would be negative 1 because it's negative 1 to the third. And the third term would be positive 1. And the fourth term would be negative 1. So this sequence, if I write it out, looks like this. 1, negative 1, 1, negative 1, dot, dot, dot. Now I want to try to take the limit as n approaches infinity of that sequence. And if I think about letting this sequence tend towards infinity, it does not converge. The sequence diverges. You might say that the sequence is headed towards positive 1. Someone else might say that the sequence is headed towards negative 1. But the sequence itself is not converging towards a single number, and therefore the sequence diverges. Now, if I look at the series, the sequence of partial sums, the first sum is 1. The second sum is 1 plus negative 1, which is 0. The third sum is 1 plus negative 1 plus 1, which is 1. The fourth partial sum would be 1 plus negative 1 plus 1 plus negative 1, and that's 0. And we could see what's happening with the sum as well. I can't write a sum formula. I'm not sure what it's going to be. It's either 0 or it's 1, but I can't write that. I can't say that something equals two different things here. This is the nth term. I don't have a formula for the nth term, but I do know the limit as n approaches infinity of whatever that s sub n is going to be would not exist. The sum does not tend towards a single number, so the series diverges as well. Would it be the case if the sequence diverges that the series would necessarily have to diverge? Remember, there's 3 flavors of diverging. This is the weirdest one. +1, -1, +1, -1, +1, -1. That means that your sequence is diverging. When you sum it up, it's going to be similar. It's just not going to be the same two numbers, but the series will also diverge. But there's other forms of sequence diverging. Another one is a sequence that is headed to positive infinity, for example. If the sequence is headed to positive infinity, if you start adding up the terms, aren't they also going to tend towards positive infinity? The other form of diverging is a sequence that heads towards negative infinity. And if you were to add up all of those terms, wouldn't they also add up to negative infinity?